Video is for topic 5.5, collision model. The objective for this topic is to explain the relationship between the rate of an elementary reaction and the frequency, energy, and orientation of the molecular collisions. The theory behind the collision model includes three parts. First, that reacting molecules must collide with each other. Second, that those molecules have enough energy to break and form bonds. And lastly, that the molecules collide in a way or in an orientation that actually allows for the breaking and forming of bonds to occur. So we're going to look at some of the different factors that can affect these three things. First thing we're going to look at is concentration and rate. So I want you to pause for a second and think, using collision theory, how would increasing the concentration of reactants affect the rate of the reaction? So collision theory says that particles need to collide in order to react. So the more often that the particles can collide, the more often or the faster it's going to react. Increasing the concentration of the reactants means you have more particles available to collide. More particles means faster rate of reaction. So increasing the concentration of your reactants will increase the rate of the reaction. Next is energy and rate. So all molecules require a minimum amount of energy to react, and we call this minimum energy the activation energy, or capital E sub A. So this is the amount of energy that you need to get from your reactants to your transition state to then be able to form your products. What we're looking at here is the number of molecules or particles that have enough energy. So you want to think about ways that you can increase the number of particles that have that activation energy available so that they can react. If you have more particles with enough energy meeting that minimum requirement, your reaction rate is going to be faster. If you have fewer particles reaching that minimum amount of energy, you're going to have a slower rate of reaction because fewer particles will collide and react. So now let's look at temperature and rate. Using collision theory, how would increasing the temperature of the reactants affect the rate of the reaction? Well, we know that particles at a higher temperature have a higher average kinetic energy and therefore a greater average speed. So we're thinking back to our Maxwell-Boltzmann distributions. So increasing the temperature means that you increase the average kinetic energy, thereby increasing the average speed of the particles. Faster moving particles are going to collide more often, therefore increasing the rate of the reaction. So then how would the temperature affect the activation energy? Well, let's look at a graph. So the activation energy for a reaction stays the same, but by increasing the temperature, you end up with more particles with that energy available to react. So at a lower temperature, you're going to have a smaller fraction of those particles with enough energy. So looking at this graph, our activation energy doesn't change. It's the same. By increasing the temperature, what you're doing is you're pushing more particles beyond that activation energy. So you have more particles with enough energy to react. So your reaction energy itself doesn't change, but your number of particles with that amount of energy does increase as you increase the temperature.